Hello, I'm Mike Ayers. I'm the Executive Director of the Illinois chapter of the American Concrete Pavement Association.
Hi, Mike, good to see you. I'm Jim Randolph, Executive Director for the Illinois Ready-Mix Concrete Association. We're glad to greet you today. Wish we could be seeing you in person. We have some great things to share with you from our industry. Myself from the producer side, we're the ones with the plants and the trucks and the mix. And Mike is from the paving side. So we have a lot of good things to share. And we'll start our presentation here. So I hope you're having a good day. I hope it'll be a good concrete day for you this season. And what I'm going to talk to you about is sustainability. That's the buzzword today for concrete. And what are we going to do to make concrete more sustainable? Have you ever really given it much thought? There's a lot being done. In fact, our industry is leading the way in sustainability. We're very green. We're going to show you how we can do that through CO2 injection, through PL1, Portland limestone cement, through fly ash, the use of slag cement. And this is related to both cement and concrete. We're reducing our carbon footprint in both arenas. So we're here to talk to you, the decision makers. And often you want to ask somebody, how do you keep from making a bad decision? Well, I never met an engineer that I had to worry about that, but this is down in Peru, another country, third world country. And I'm not sure if the pavement went in first and then the pole later, or if they paved around the pole. But I see a lot of things here that are wrong with this picture. I'm going to zoom in a little bit, and that rooster up on the pole is says no cockfighting. That's important. So you have to drive in the left turn lane to read that. A little further to the left, you see a black sign. I guess it's facing the other way. Would that be wrong way traffic? Somebody coming from the other way to turn in towards the pole? I don't know. But obviously, if you don't make a good decision, things have to be done over. In this case, there could be accidents, but I thought it was a very interesting picture to be sure. Our slogan for 2021, our vision, if you will, is design with concrete. And I'd like to invite you to go to our website, www.irmca.org. And you'll look for the IRMCA webinars, blue box on our homepage in the top right corner. And I'm going to give you resources today. I'm not going to give you the presentation, but I just want to give you the resource for how to specify carbon cure in your concrete and how it can lower CO2 emissions. That will be webinar 5. It's a 3-part series, part 3. You'll see that on our webinar website. And it's also going to talk about how you can focus on concrete's ability to meet current LEED requirements and meet their ESG goals. Wow, CO2, that's the carbon that we're trying to be rid of. A company named Carbon Cure, that is a new member of the Illinois Ready-Mix Concrete Association, manufactures a technology for the concrete industry that introduces recycled CO2 into fresh concrete to reduce its carbon footprint without compromising performance. That's the best of all worlds. How do we do that? Carbon Cure injects a precise dosage of carbon dioxide, CO2, into concrete, where the CO2 becomes chemically converted into a mineral. Once it's injected, the CO2 undergoes a mineralization process that becomes permanently embedded, thus results in economic and climate benefits for concrete producers, truly a win-win situation. You want to specify carbon cure in your concrete because it is not only reducing the amount of carbon emitted, it also reduces the amount of Portland cement required in the mix. For every pound of Portland cement that we can replace with CO2, there's that much less carbon emissions from the manufacturing cement plant. So it really happens in more ways than one. If you'll go to that part 3 series, you can get a 45-minute detail on that. Another way, design your concrete. This has just come out in the last few years, at least to be well known, and that is Portland limestone cement. What is Portland limestone cement? Well, Portland limestone cement is made by taking limestone and crushing it to a finer blend than even the cement clinkers are. And they can become cementitious when blended in the clinker kiln, and it creates a cementitious product, again, reducing the amount of cement that has to have additional heat to make the final cement product. Again, it's somewhat technical. It's very easy for me to say that we come in with Portland limestone cement, that we're going to reduce our carbon footprint at the cement mill. And we're getting high performance concrete with that. So if you go to our webinar number 4, 3-part series, number 2, you'll see that, and you'll see this title that I'm showing you on the screen. So let's talk a little bit more broadly about sustainability. We've been for years using fly ash, which is a result of coal-fired power plants that would have to go into a landfill or be used in some other way, disposal. And we can use up to 30% plus of fly ash replacing cement, Portland cement, in our concrete. How is that sustainable? It is because you're reducing, again, the amount of cement produced, and you're doing away with a waste product in the fly ash. And what's great is it gives us high performance concrete at the same time. You've heard more and more about slag cement, and I can go into greater detail of how these molecular structures are different and how they create this high performance. But the slag cement is a byproduct of the steel mills and their kiln process of heating up the molten metal. And slag cement also can be used as much as 60% replacement in concrete. And so you've got these ingredients of fly ash, slag cement, Portland cement, and you can use a combination of all three to make a ternary mix that gets you, again, high strength, workability, and durability. We can also use admixtures to reduce the amount of Portland cement required in concrete to get the strength and performance you're looking for. So all of these methods, your producers are highly trained and highly skilled in making the correct recipes, tested recipes, proven recipes to make long-lasting, durable concrete, and even in the high performance arena. Now here's a whole nother way to use cement and to reclaim roads. The fewer times that you have to redo a road, the lower the carbon footprint. This is full depth reclamation with cement using a ready-mix concrete truck, putting out a cement and water slurry. How do you do that? Well, you just use the existing roadway, which is often in a county road situation, an A3 type pavement, oil and chip, and you roto mill it and break it all up in place. Then you come along with your cement slurry over the top of it. You run the roto mill over again and just blend them together. Then you take your rotor grader, your motor grader that you all have in your townships, and you grade it smooth, you grade it level, and you come over it with a roller compactor. It will set and harden and be durable and long lasting. You won't have to oil and chip it for years to come. Another way that we're sustainable is by reducing the amount of concrete you need. Now that doesn't sound right. We want to sell as much concrete as we can, but we want to be sustainable as well. So we can do this by placing concrete over existing pavement. In most cases, we bond the concrete to the pavement, which creates a composite pavement. What you're seeing in this picture here is Imperial Bondware, a factory that makes our cups and plates for McDonald's and KFC and Dairy Queen and so on. And on this lane down to the warehouse, they have 13 trucks a day come in with 80,000 pound loads, go to the warehouse, offload, reload new product, and come out with 80,000 pounds. So this road has been beat by 26 80,000 pound 18 wheelers and on a daily basis. A lot of traffic, a lot of heavy traffic. What you're looking at is broken up asphalt that was the second pavement they put in. This place had asphalt, they took it all out, put asphalt again. This is the third time we overlaid that existing pulverized asphalt with 6 inches of concrete. That's before the concrete overlay, and this is after. And more than 12 years later, with this all being cut in 6x6 panels, which is important, it is performing. There's only a broken panel or two, and it's where they've had to roll off or they've distressed it in some other way. But it's this particular factory ended up doing their entire 5 acres with concrete overlay, and they're extremely, extremely happy. They're going to do the same thing at their other facilities because it's lowered their maintenance costs. So instead of putting in 8 or 10 inches of concrete, we're only putting in 5 inches on an existing pavement. So we didn't take the existing pavement out. So how is that sustainable? We're saving diesel emissions by removing the old. We're saving concrete cubic yards by putting down a thinner amount because we've made a composite pavement. So you can certainly work this and intertwine this into your leads and your other environmental incentives. And so here's an interstate just outside of Springfield. I think it's at least 10 years old now. High performance, concrete overlay on existing asphalt. And we hope to see more and more of our interstates go with concrete overlay. It's one and done, probably last 25 years, probably designed for 2025, probably last 40. We'll see, but we need more of these. And now with the push on sustainability, it makes even more sense to go with the concrete overlay. Our county roads throughout Illinois are now putting concrete overlays on their existing asphalt, getting high performance. Our villages, 80,000 pound roads, they're putting a 5-inch overlay on their existing roads. So this goes faster, takes less money, and the initial cost is very competitive. So I'm really glad to have this time with you. And I want to direct you once again to our website, IRMCA.org. You could give myself a call at the phone number listed there or my email address, and would like to go in greater detail. And if you have any questions, we would be more than happy to take your questions and get back to you with some answers in the days ahead. Thank you again. Here's Mike Ayers.
Thank you, Jim. All right, we're going to talk about concrete overlays as a sustainable solution for your existing needs. But we're also, before we get into that, going to talk a little bit about sustainability concepts, about pavement preservation techniques, the things that might work for you in your particular circumstance. So the first thing we look at is a pavement management system. Do you have a cohesive management system in place? What kind of data do you collect? And from that, how do you analyze it and make informed decisions about what's the best avenue for your money? So we are going to term first pavement preservation. It's a network level long-term strategy. It's not project specific. It's simply a way to look at your system and over the course of the next 10, 20 years, what is the best bang for the buck? So we have a lot of different preservation techniques that we readily utilize, but they all have some commonalities. They're cost effective. They're applied to structurally sound pavements. They maintain or improve the functional condition and does not increase necessarily the structural capacity. So structural capacity of a pavement is the ability to carry the imposed loads without premature failure. Functional condition is the road may be able to carry the imposed load structurally, but for some reason it's not serviceable to the public. It could be rough, it could lack friction, it could be noisy. There's a number of different things that we look at in terms of what is a functionally good pavement versus a structurally good pavement. So concrete pavement rehabilitation, the way we've typically looked at things is we have 3 steps. We do pavement restoration on a limited basis, followed by resurfacing when the specific restoration techniques are no longer economically viable. And finally, if overlays are not working because we have drainage issues or we have underlying issues with materials, we may look at reconstruction. Rehabilitation is intended to improve the structural or functional capacity of the pavement. So it is by definition going to be more expensive to do concrete overlays or reconstruction than it is to do selective restoration. So these are the three categories that we look at in terms of what could we do with an existing concrete pavement. Well, we have rehabilitation costs versus time or traffic. Over time, every pavement deteriorates. Even if there were no loads on the pavement, it would still deteriorate due to material degradation. That's applicable for concrete, composite pavements, and asphalt pavements. But in terms of concrete pavements, we have a very slow rise in that curve. In other words, we don't have to do a lot in order to keep the pavement in serviceable condition. If you look back historically, the interstate highway system back in the 1950s, 1960s, they were designed for 20 years. Some of those pavements are still in service. A lot of those pavements that are in service could carry 10, 15, even 20 times the design level of traffic. So we have moved out of the pavement cycle where we have to go out and do repetitive maintenance or repetitive repairs every other year or every third year. We actually have very long intervals in restoration. Federal Highway Administration a couple of years ago really was pushing heavily on preventive maintenance strategies. And that essentially said, I'm going to go out when I see any distress on my pavement, I'm going to spend the money to fix it now rather than to let it deteriorate into a worser condition. $1 today, it's often said, will cost you $5 tomorrow if you wait in terms of pavement repairs and restoration. So rehabilitation, again, is what we are typically going to look at up front. And so this talk is going to talk about restoration techniques as well as resurfacing. The restoration procedures we typically would look at start off on the lower left and go to the upper right. If we have voids under the slab, we have visible areas where the support conditions are less than adequate for the pavement, we might do slab stabilization, where we inject a material underneath the slabs in place to restore load transferabilities, to restore the uniform, which is what we're trying to get, uniform support under the slabs. If we have some type of a drainage issue that we've identified as driving the distresses, we can retrofit edge drains on very much any pavement that's out there. But now we get up to the more common types of repairs. Partial depths, full depths. Those are done more than anything else with the exception of diamond grinding. Dowel bar retrofit, if you have a lack of load transfer at transverse joints, we might want to come back and install dowel bars to effectively increase the longevity of the pavement. Cross stitching, if you have a longitudinal crack in the pavement and you want to completely immobilize it, cross stitching or slot stitching is certainly an appropriate technique. And then finally, we get up to joint and crack resealing. Every pavement responds to moisture in a negative way. So one way to prevent moisture from intruding into the pavement from the top down is to simply seal or reseal joints and cracks that have developed in the pavement. So pavements start out at a specific level of condition that's tied in very heavily to the as constructed qualities of the pavement. And if you had to pick one thing, it would probably be smoothness. That's the way most of us, as we drive down the road, assess performance. Well, over time, pavements accumulate structural damage. And finally, they get to the point of terminal condition. And terminal condition doesn't mean that the pavement is no longer able to be driven on. It simply means that it is the end of its design period that we anticipate. That may be 15% cracked slabs. That may be joint faulting of 1/4 of an inch or 1/8 of an inch. It depends on the type of facility that we're dealing with. But every pavement starts off and follows some curve based on the design and the construction and the environment that's exposed to. So there's a minimal acceptable rating. This is generally where every agency is going to go out and intervene in the roadway. That might be preventive maintenance, that might be an overlay, but something has to be done at this point to keep the traveling public happy. Now, the rehabilitation measures that we're going to employ, and again, there are a lot of different things we can do, will restore the condition of the roadway to the level that you desire. We can, through selective repairs, fix the roadway and make it as smooth and as serviceable as new. The more that you do to bring it back to that level, the less money you'll have to spend in the future, which is the whole concept of preventive maintenance. Well, over time, that rehabilitation that you do is also going to deteriorate back to a point of minimal acceptability, in which case you can come back and you can do this cycle again. But if you'll note the interval between the first curve and the second curve, it's less on the rehabilitation side. The reason for that is that pavements accumulate damage over time. And you can't correct that because it, again, is an accumulated damage, not a visible distress. So what that essentially means is that if I put 1 million load repetitions on the pavement, it doesn't necessarily crack. But occasionally, if I put 1,000,001 load repetitions on the pavement, it will crack. The difference between those two things is what we're discussing here. The accumulated fatigue damage in the pavement is why that second interval is less than the first. So rehabilitation strategy is not a terribly complex operation, but it can be an expensive operation. So what we want to do is look at the information that we have available. We want to look at historical records. We want to look at performance history. We look at the overall cost to own that structure. And then eventually we select the preferred alternative based on many different factors. Because as I said, we can do partial depth, we can do slab stabilization, full depth repairs. There's a whole range of things that we can do. So now we're going to get to overlays. This is the step that we follow past pavement restoration. When pavement restoration reaches a certain threshold value that you'll have to establish for yourself, it becomes cheaper to actually do a universal fix, which is a concrete overlay. This overlay guide is a free download from the Concrete Pavement Technology Center at Iowa State. And it will tell you everything that you need to know about designing, constructing, and rehabilitating concrete overlays. It is an excellent reference material. What can we use overlays for? We can use it on intersections in urban areas, secondary roads, urban freeways and interstate, urban arterials, primary interstate highways. There's no end to the things that we can do. We overlay major airports, runways, taxiways, aprons. We've done overlays on huge industrial facilities. So in addition to these relatively smaller scale projects, we do some very large scale overlays. So the benefit of concrete overlays essentially boils down to a couple of things. It's going to save you money over time as opposed to an asphalt overlay. Concrete overlays, if properly designed and constructed, can easily last 20, 25 or more years. The routine maintenance activities and the restoration activities during that period are very much minimal. They're easy to maintain, they're easy to fix. One of the things in urban areas that we frequently deal with is what about utility repairs? Well, if we do, let's say that we have an existing asphalt pavement and it has buried utilities, and we put a concrete overlay on the top of that. It is not a difficult thing to saw and remove selected panels in order to service those utilities. We can reestablish support under the pavement by using low-strength flowable materials, flowable fill. We can restore that support using compacted granular material and simply replace the surface after we're done with the utility repairs. It shouldn't be a detrimental point with concrete overlays that they're difficult to fix in urban areas, because they aren't. And one of the things that we looked at in the past is improving surface reflectance. So your amount of light necessary to illuminate an urban area is significantly reduced. We actually have studies that show that you can use far less energy to give the same amount of light into a parking area, into city streets. And this is a real cost savings in terms of dollars, but it's also very sustainable if you want to look at it from the environmental aspects. So there is, on the acpa.org website, something called the National Concrete Overlay Explorer. And it tracks a portion of the overlays that have been constructed in the US. You can sort them by the overlay type. You can sort them by thickness, by the functional classification of the roadway, and various other aspects. It's a very powerful tool if you'd like to go online to see what comparable pavement sections have done around the US. When this overlay guide was put together, or overlay explorer, we didn't necessarily differentiate between good and poorly performing overlays. So if there's a particular design that was not overly successful, it'll still be in this overlay guide, book, or explorer, however you'd like to term it. So this is a good source of information if you want to look up projects to see whether you might want to construct something like that. Illinois has lots of concrete overlays. We have hundreds. The vast majority of those are county roads, urban, and we have some major interstate projects like Jim had mentioned on I-72 around Springfield. Those are long-lasting, high-quality, high-service pavements. And over the course of time, you can go back and you can look at actually do a comparison between other pavements in your network compared to the concrete overlay to see which is the most inexpensive to own. There are two general classifications of overlays. There's bonded overlays and there's unbonded. With the bonded overlay option, the one in the upper left, over asphalt, we probably do more of those than anything else in the state of Illinois in terms of concrete overlays. They are cost effective, they are minimal maintenance, and they are very easy to construct. When you're dealing with the bonded overlay family on the left-hand side, the bond becomes an integral part of the design. The concrete and the asphalt bond together to form a monolithic structure. So we actually have some of the load carrying capacity of that pavement embedded in the existing asphalt. On the right-hand side, you'll see a concrete overlay over an existing asphalt pavement, but it seems to be much thicker. That is because it is. The overlay on the left, we have built those anywhere from 2 inches to 6 inches. On the right-hand side, when it's unbonded, we are essentially constructing a new concrete pavement on an existing asphalt base. That pavement may be 9 inches, 10, even 11 inches thick, whereas the one on the left hand is probably more in the order of 4 inches, even for fairly heavily trafficked roadways. So asset management through concrete resurfacing, where do we fall on this curve? This is a little more detail oriented. We saw that curve before where we showed the restoration or the rehabilitation cycle after the initial behavior. Well, this breaks that down to a little greater extent. We can do preventive maintenance. We can do long-term repairs that will actually keep the pavement in a high level of service for a very long time. But at some point, that is no longer cost effective. For instance, if you see the preventive maintenance, we're talking about the need for full depth repairs. So you have a transverse crack that's opening up in the pavement and you want to repair that to keep moisture out, to keep incompressibles out. You could do a specific full depth repair relatively inexpensively. But what happens if every 5th slab exhibits that kind of behavior? We move down then into the rehabilitation cycle where we're doing substantially more than trying to maintain the pavement in a certain level of serviceability. We're actually down to the point where we are fixing it to keeping it in surface. Well, the type of overlay that you employ depends on where you are on this curve. And if you download that concrete overlays manual, it will tell you all the steps to follow in terms of selection. So the overall goals of project selection is we are trying to pick the overlay that best suits a specific condition. If you have a pavement that's in very poor condition, the most likely type of overlay that you're going to build is going to be an unbonded. If it's in reasonably good condition or somewhat marginal condition, then a bonded overlay may be appropriate. There's ways that we can do the design of these pavements and do a cost comparison to determine which is the most cost-effective means to get X level of service. Do I want this overlay to last for 10 years? Do I want this overlay to last 25 years? I just came back from doing a job where we are looking at how to buy 3 years in the life of this pavement, because the budget to completely reconstruct the pavements kicks in year 4. So what are we going to do that buys us 3 years? Well, we're certainly not going to put a heavy overlay down, but we may in fact put a very light concrete overlay that will, for all intents and purposes, give us the 3 years. And yes, we have design programs that will calculate that out. So the condition of the existing pavement is obviously important. If it's in good condition, bonded overlays are a fitting solution. If it's in very poor condition, very likely you're going to be building an unbonded overlay with a separation. Keep in mind that if you're putting a concrete overlay on a concrete pavement, whatever distresses are existing in the existing concrete will likely reflect through to the surface. The same is not true for putting a concrete overlay on an existing asphalt pavement. We may have to fix areas of structural failure in the asphalt, but we don't have to do much surface preparation. The asphalt modulus is so much lower than the concrete that if you have cracks in the asphalt or you have minor alligator cracking or other types of distresses, they won't propagate through the concrete. So we might want to do some selective coring and laboratory testing, depending on the importance of the project. We're almost always going to want to pull a few cores. We want to look at the level of distress in the pavement, doing a visual survey, but we also do need, in terms of calculating out the required thickness, we need to know what we have, what we're dealing with. So we can do selective coring. On the upper right-hand corner is the dynamic cone penetrometer, which is a very useful tool. in terms of trying to characterize subbase and subgrade materials. We can do exotic testing. The lower right hand is a falling weight deflectometer. You can get a wealth of information from that device in a short amount of time. And if you have an important project, it's worth hiring the FWD crews to come out and actually thump the pavement. And we can use those numbers to back calculate support conditions. And basically, we calculate all of the required parameters necessary to design the overlay. So a bonded concrete overlay of existing asphalt or composite pavement. This is the one I mentioned a little bit ago. We have built 2-inch thick concrete overlays on existing asphalt. I frankly would not tend to do that. There's a number of reasons for that. If you have very light traffic and you're simply trying to increase reflectance, you're trying to give a good non-skid surface, you're trying to get a surface that doesn't require a lot of resurfacing every few years, then 2 inches may be appropriate. But if you have any substantial truck traffic at all, 2 inches is likely not going to be sufficient in terms of structural capacity. As I mentioned, we do a lot of 4-inch overlays, and we do 4 inches on existing asphalt pavements in moderate to poor condition with minimal preparation required. And we can get 25 years out of some of these overlays. We have had overlays in place for that period that are showing very little in terms of distress. Now, there are obviously a number of tricks of the trade that have to be employed in designing these. Joint spacing is very different. We typically use fibers in the concrete. We probably are going to mill the surface in order to get a good bond between the concrete and the asphalt. Because remember, if we don't bond to the existing asphalt pavement, that thin concrete overlay is going to fail under truck traffic. You may have heard this or in the past, but it is nonetheless still valid. 10,000 cars do roughly the equivalent damage of one 18,000-pound single axle load. Now that's for a high type roadway, but it's still more or less the same for a smaller, thinner overlay project. So do we absolutely have to mill the asphalt? No, we do not. But it's to your advantage to do that. Milling is relatively inexpensive. You can use the millings, you can recycle those, you can dress the shoulder with them. But it allows us to put down a more or less uniform thickness of concrete, which is important. It allows us to match existing lanes. But the most important thing is it enhances the bond, and the bond being all important. So one thing to remember, and this is something that has come up several times in the last 6 months. If I mill my pavement, I'm expecting to do a bonded overlay. Well, I need to have somewhere between 3 and 5 inches of remaining asphalt after I mill the pavement. What you see in that photo is the milling operations went clear down to the subbase, which means I do not have adequate asphalt to bond to. Well, if I can't bond to the asphalt in order to transmit some of the load, then my overlay is not feasible. I'm going to have to go back to the drawing board. So if this is one small area, the rest of the pavement I've cored out and I figure I'm okay, but this one area was very thin. I can come out and I can take a backhoe and I can dig out that specific area, and I can put in asphalt and roll it out. I can put in flowable fill. I can also put in concrete, a lower quality concrete, and strike it off with the surface. And then when I put my overlay, I have uniform thickness and uniform, more or less uniform level of support. So in order to get the bond that I desire and need, I'm going to clean the surface. I'm going to power broom it almost always, and then I'm going to air blast it or water blast it depending on the circumstances. I can place it with a slip form paver. If it's in an urban area, I can form pave it. I can put down with a vibrating screed. If I wanted to, I could put a short area down, striking it off with nothing more than an edge tool or a strike off tool. Joint sawing, absolutely critical, as is curing. You have a very large surface area, a very small volume of concrete, and it tends to give up moisture very quickly. Therefore, it's going to crack unless you can get the curing compound on it soon after placement. If you cannot put the curing compound on it for some reason, you can spray it with an evaporation retarder that will buy you a little bit of time before you actually do put the pigment and curing compound on. We have to saw it quickly. We have to use early entry saws, and we have to have sufficient saws on site to be able to accomplish it before the pavement cracks. What I'm getting at is your window of opportunity for sawing is much less than the conventional pavement. And the last thing about these types of overlays, as a rule, if the overlay thickness is in inches, the corresponding joint spacing is in feet, and it's a 1-to-1 mapping. 2-inch overlay, 2x2 panels. 3-inch overlay, 3x3 panels, and so on. But what you want to avoid at all costs is putting a longitudinal joint in the wheel path. So as you can see in the upper right, the 4x4 panels will put that inner wheel right in the wheel path. So you need to adjust your spacing on joints to accommodate that. So bonded concrete on existing, there's the key points, and we've talked through those. The only one that I wanted to mention that I didn't up to this point is that you need to have the surface temperature of the asphalt below 120. Because when you put the concrete on, there's a good likelihood that you'll stress the concrete by that high heat. So putting on a very thin mist of water and allowing it to evaporative cool the pavement prior to placement is a good idea. But you want to make darn sure that you don't have water ponding. We have unbonded concrete on asphalt or composite. And again, these are just constructing a new pavement on an existing pavement. The existing pavement doesn't have to be in even minimal condition to make this work, because you are assuming that the existing pavement is nothing more than a base course. So it is appropriate for severe rutting, potholes, alligator cracking, shoving and pumping, decracking and ASR if it's a composite pavement. You can do this, and you should do this when the existing pavement is not something that you can bond to and add structural capacity to your overlay. And again, a lot of the same criteria applies, the 120 degrees. Partial bonding in this case is actually okay. It helps you, it doesn't hinder you. The last overlay we're going to talk about as briefly is this unbonded concrete on concrete. You can put this on a really severely distressed pavement like you see on the lower right. And the key is that you're going to separate the old pavement and the new pavement. And you can do that by either putting down a thin layer of asphalt, generally less than 2 inches, or a specifically designed geofabric, as you see in the bottom right photo. So what about historical perspective? Do these actually work? This is a summation of what's in Iowa, because Iowa has traditionally kept very good records on their overlay projects. And as you can see, they have somewhere around 1,900 miles of concrete overlays in the state. They have written a guidebook as to what the historical performance has been. But generally speaking, most of their overlays are 20 years or so as being the oldest. And they have, for the most part, performed extremely well. So the oldest in Iowa is 1977 on asphalt. On concrete was 1980, 2 inches to 12 inches, and panel sizes from 3 feet to 40 feet. We've used that in great measure to do the overlay guidebook that I referenced before. So this is the results in the analysis. And I know that is somewhat difficult to read, but the bottom line of that is the vast majority of the overlays, regardless of age in Iowa, regardless of the thickness and the type of overlay, are still good performing. So there's the case history publication that you can download from the CP Tech Center as well. And it's worth looking at. And here's one from Illinois. County Road 56, LaSalle County. You can see the alignment. 5 to 7 inches thick. It's 40 years old. It's carried now, this is a few years old data, carried somewhere in the neighborhood of 9 million equivalent single axle loads. It's unbonded on asphalt. Common sense would tell you, based on what I've said before, that you need a thicker overlay. But this overlay has performed extremely well. The existing 18-foot wide asphalt was redesigned and widened out to 24 feet. There were no reinforcing bars. There was no extraordinary measures taken. The overlay was simply placed and extended out past the existing asphalt. And there's the section. And 5 to 7 inches of concrete is borderline on load carrying capacity in terms of heavy trucks. So we design only for trucks. We don't design for cars. So there is the integral widening. There's the final product. Diamond ground, one of those early restoration procedures we talk about after 28 years. Minor patching where you had a lot of heavy trucks turning and coming out of the elevator. And the last question that you might have is regarding staging. How difficult is it to build this? Can I build this under traffic? The answer is yes. We have a lot of case histories documenting the how-tos in order to stage effectively. In an urban area where we routinely do, we have an asphalt intersection that is prone to failure from shoving and rutting. Can take possession of that intersection, shut down the intersecting roadways on Friday night after the traffic passes, prep it, place the concrete, and open it to traffic prior to Monday morning's opening. So yes, we can do it. We can do it in an urban area. We can also do it in rural areas. Highway 18 in Iowa was a perfect example. 2-lane rural road constructed under traffic with 0 accidents and very, very quick turnaround on opening. So there is a wealth of information out there. And we do overlay talks routinely within the state via webinar. And when we get back to some level of normalcy, we'll be glad to come out and talk to you about these techniques, preservation, economy of scale, various other aspects of sustainable types of solutions for concrete. And with that, I welcome you to send me a text or email me at mayors@acpa.org, and I will be more than happy to answer your questions. Thank you.
Mike, it's really been a good session for both of us here, and we're on the material side and you're on the paving side.
Yes, sir.
And, you know, we're saying design and concrete. We're talking to designers here. We have a lot of public works engineers here. And so I just wanted to let them know that our industries keep current with all the latest ASTM, AASHTO, ACI specs when it comes to materials, and you do as well.
Yes.
When things go down. And so Unfortunately, not everybody on the design side, like that guy in Peru, uses current data.
Mhm.
Well, with it being on the internet, everything is fresh and new, and we're sure to do that. Another thing I wanted to mention was that the capital bill of 2019, we're seeing the fruit of that now. So the people we're talking to here should be seeing funds that they can do some rehabilitation or new construction. And this is the opportune time to make the best use of their money, because when they do it in concrete, they're one and done. Right?
Yes, exactly.
So if you're not getting that funding, be talking to your council or your county and see where those funds are and how to get them there. So it is very cost effective. People often say, well, concrete's going to cost me more in the first place. So what we're finding is design and concrete. If you want to get an asphalt alternate, then we have one more step.
Mhm.
Please get a design in asphalt that is apples to apples. For years, that's not been the case. And you can actually go to our website, and we have one of our webinars that is there to be viewed on how to design asphalt pavement. So you can get the comparison from an asphalt engineer. So you're a concrete engineer, Dr. Ayers. We have asphalt engineers. All we want is a fair comparison. And the decision is pretty simple to make.
Exactly.
So
If you have not been on the site, I would recommend that you look at pavementdesigner.org and just look at what the design requirements are for concrete pavements. They have new construction, overlay construction. There are segments on industrial paving. It's a very powerful resource. But I'd like to stress that both Jim and I are more than happy to come out and help you with whatever you need. We went up to a city not long ago and did some coring. We pulled up samples. We actually did a very preliminary design, and we can walk you through the process as well as help you with funding requests, that sort of information in terms of how we're going to approach the overall structure.
sounds good. I'm ready to pour some concrete.
I am too.
All right. Give us a call, and thank you for having us. And we want to say thank you to the APWA organization, and hope we get to meet you once again. We will be back in July live at the Chicago conference. So see you there.
See you there. Thank you.